So, as we all know that per capita energy consumption is an indicator of development. So, demand of practical engineering is increasing exponentially, whereas installation of new generation transmission capacity could not grow at the same pace. Because of economic reasons, because of environmental reasons, putting a plant is, capital intensive thing. So, there is a gap between the demand and supply as usual. To bridge this gap, electrical engineer thought to try many things. Okay, so what was initially the aim? There was a crisis of electricity in 1970 when the petroleum prices hike was there from oil exporting companies. So then people started thinking what to do. So then the thought came that there are 3-4 strategies which we should adopt. Number one, better utilization of existing infrastructure. So whatever you have, try to use it optimally. Number one. Number two, improve technical efficiency of the system. Number three, improve commercial efficiency of the system. These are two different aspects. Commercial efficiency is related to business. Technical efficiency is related to your system. So then there was an effort to improve technical efficiency and commercial efficiency both. And for this, they need a shift in paradigm. Total change of thought came into mind. So what to do, how to do. Okay, so let me quickly brief. So then they thought that because we have energy scattered all around the world. Initially in the ancient time, we used to put big power plants in remote areas. And they found that energy is available everywhere. In the form of solar energy, in the form of biogas, in the form of wind, everywhere. So then the thought came that why not take every possible source of energy, wherever it is available, put it to the grid. So small tapping of energy started coming into. So then again, initially you were supposed to pump energy in the system from somewhere else. So this design worked like that only, that we are injecting energy from this point. We cannot inject energy from here. But then when you start thinking that take every possible source of energy and put it to the grid. That means you can install a solar plant at your rooftop and you can give this energy back to the system. Now it's reverse. Where you are supposed to take energy, you are pumping the energy back to the system. So this led to definitely a lot of technical drawbacks. As I said, because I cannot go according to slides, there are 45 slides and you are already running out of time. So what is happening around the world? Non-conventional energy sources are being added. The emphasis is on better utilization of existing generation and transmission facilities. As I said to you, rapid and critical changes are taking place around the world in the way that it used to be generated, transmitted and distributed. There is a total shift. Earlier there was one company that was supposed to be generating electricity, transmitting electricity. We call it vertical structure, where generation, transmission, and distribution was owned by one company. Now it's changed, horizontal system. You can have multiple generation company, you can have multiple transmission company, you can have multiple distribution company. So things are changing very fast. So now I will quickly, as I said, I will not go into detail of what is happening. So optimally utilize the available infrastructure. Hengorani, an Indian, serving in Canada, gave the concept of FACTS, flexible energy transmission system. The ultimate aim was better utilization of existing power and energy infrastructure, controlling power over designated transmission route. This is very important. According to your Ohm's law, power flows from higher potential to lower potential. Through these technology, you can reverse the flow of power from lower to higher. This was the beauty of this technology, that you can control the power in desired fashion. So this was the one thing that came into existence around 1987. Idea was to improve the efficiency, better utilization of existing infrastructure in generation, transmission, distribution. This led to development of various FACTS devices, flexible energy transmission system devices. Okay, I will quickly skip this part. So these are the devices that came into existence, and research is still on and the development of these devices, static one compensator, static synchronous compensator, all these technical things which many of you might not be knowing. But you know, these devices came into existence to improve the usability of existing infrastructure. Okay. Then, as I said, first objective was to improve optimally use the existing infrastructure. Second thing was to improve the technical and commercial efficiency. Then came the restructuring and deregulation. The aim was to, increase competition in the generation sector, transmission sector, and distribution, and to improve the reliability and efficiency of the system. So, around mid-80s, somewhere around mid-80s, throughout the world, there was a change. The company were split into different companies. Earlier it was one company, Power Electric Utility used to be called. Now it is Gencos, we call it generation company, Transco, we call it transmission companies, Discos and all. Idea was improving technical and commercial efficiency. So this was something on the commercial side. So when they restructured the companies, then definitely they had to restructure the electrical system also. So this all concept led to the privatization, restructuring, and finally deregulation of power. What is the meaning by deregulation of power? Earlier the power was regulated by this one regulatory authority. Now it's deregulated in limited sense. That means you can also generate power. Earlier it was not the case. Private people could not generate power. Now government has opened up. You can also generate power under certain restrictions. Now government now. So we call it deregulated power. So deregulated environment has initiated reforms in our power sector. Now the important thing is, earlier it was electric company. They used to say, we'll supply you, will not supply you. It was their choice. Now consumer has become the key. Consumer says, I'll not take supply from you, I'll take supply from this firm. So in future, what will happen? You may say that I want power from Reliance. Person sitting near to you, you can say, I want power from Tata. And I want power. So ultimately, consumer will be the key, and consumer will be selecting taking power from different companies. So we need to design our system. Research area is this. You need to design your power system in such a fashion that you can take power from any electric utility you want. Be it Tata, as I said, this is not present situation. This is what we are visualizing. In future, consumer will be everything. Like you go to market, you buy the shoe of your own choice. I want Woodland, I want Nike, I want this, I want, so you are paying for it and you can buy it. So consumer has become key. So as I said, these are the result of restructuring. That company split it into Gencos, Transcos and Discos. Then the concept of a smart grid came into existence. You all know the word smart grid, smart distribution system. What is this all about? Basically, this is the concept given by USA, and we all follow it. This is intelligent grid. We call it a smart grid because US people call it a smart grid. Energy Independence Security Act of USA gave this concept. So what is smart grid? It is nothing but grid along with communication, two-way communication, distributed computer, data transfer from consumer to the company. This overlay is called transform grid. So, I just want that you know what is happening in electrical thing. I don't want to go into the detail of what is inside. So, first thing that came into existence is development of FACTS devices, flexible AC transmission system devices. Then came the concept of deregulation, where the companies split it into different companies. And then now the concept of smart grid. What is smart grid? Transform grid that uses robust two-way communication, advanced sensor, distributed computers to improve efficiency, reliability and safety of electric supply. This grid should be environmental friendly also because you are putting renewable energy. So this was the Act ESA, we call it ESA 2007 Act. Under this, they defined the philosophy, they visualize what should be in the smart grid. These are the future grid that uses digital information and control dynamic optimization of grid operations and development and integration of distributed resources especially renewable development and use of demand response, development of smart technology for meeting and communication. I'll take few points because, you know, development of smart appliances, use of peak shaving technology, including advanced storage, all these things comes under, this is visualization. They think that in future power system, we can achieve these goals. It's not present as a situation. What are these? I summarize. Take every possible source of energy and put it to the grid. Wherever energy is available, be it a hydro, be it a small wind turbine, anything that is available, you put it to the grid. This is one thing. Second is integration of smart meters. What is smart meters? Smart meters is again two each other. A smart meter gives you information about what is the rate of electricity right now. And then it gives utility what is the demand of the consumer right now. So if the demand is high, supply is less, the people sitting in the company, they can decide the prices. Okay, hike the price, because this time the demand is high and supply is low, so they will hike the price. The consumer will know this time the price is very high. Let us change the consumer consumption pattern. Don't use electric iron right now. I can iron my clothes in the night. Don't use washer. I can wash my clothes in the night because this time energy rate is 20 rupees a unit. So you change your consumption pattern. This is the advantage of smart living. Number one. Number two, you have smart appliances. In future you will have smart appliances. You know, you are chatting with your friends in some hotel and all of a sudden you can come to know that there is a price reduction in electricity. So you switch on your washer and all that sitting in the hotel from your hotel through internet. It will go wireless, it will switch on your washing machine and other things, and you will use electrical energy at lesser price. Number one. Number two, you can have, on your rooftop you have some solar panel installed. You know, you are storing that energy. Okay, you have battery system, you are storing that energy. And when you come to know the price of electricity is very high. So you say, okay, supply my electricity to the grid. So you will sell electricity to the grid. This is what they are thinking. And this will happen. This is happening in the US also. So, use of peak shaving technology, including advanced storage technology. What's the meaning by peak shaving? Peak shaving means basically, effectively, you are reducing the peak demand by means of other things like dynamic pricing. You are increasing the price so that people are using less energy. So that is when peak is reaching, so the cost is very high, you will cut down your usage. One way is this. Another way is that when you have this kind of thing, you will buy energy from local sources. So these are the things that is happening around the world, and as I said, I will not take much of your time. This is the future power system, how it will be visualized. Now, so smart grid is nothing but basically is a system which supply to different distribution system, and distribution system are the systems which are connected to you directly. So the thing of concern to you is smart distribution. So major changes are taking place at distribution level, because you know that majority of the reliability issues emerges from distribution system, and therefore we need to concentrate on distribution system. So again, ESA, Energy Independent Security Act 2007 of USA, defines the philosophy of a smart distribution system. What smart distribution should have? These are the. I'll just show you the slide. You note down anything if you do not know. I'll explain you, because to cover up all the things in such a small time, it's not possible. So you see, DER, peak shaving, self-healing, sensing, consumer devices, optimization, highlighting, advanced tool, and command response. Some of the things are related to electrical engineering, and some of the things you all can understand. Resources, you have to optimize your resources. It's simple. Then you have self-healing. If you have any problem in the system should be capable of detecting it, and should be capable of disconnecting and connecting some switches so that the system power is restored. I have multiple feeding to him. Okay? If there is a problem in this route, it will sense, relay will sense that yes, there is a fault. It will cut this feeder and switch on this feeder to him. So this is kind of self-healing. To know the self-healing, you need to have diagnosis system. So you need to have good sensors. So everywhere sensor will be deployed, it will be even at distribution level so that you know the health of your system. So these are the things. Consumer devices will be smart. As I said earlier, distributed energy resources and reshaping DR means putting a lot of renewable small energy sources, every possible source of energy to the grid. Demand response, the pricing should be dynamic. Demand response means changing the usage pattern of the consumer. You have a set pattern of consumption. You get up at 6 in the morning, switch on your geyser and all that. Okay? Now I am electric utility, I just want to change your pattern. So what I will do, I know that you use electricity at 7 in the morning, I will say the price is 20 rupees per unit. And if you use the same energy at 9, I will pay the, I will charge the tariff of 2 rupees. So you say, okay, fine, why should I switch on my geyser at 7 in the morning? I will switch on my geyser at 9 in the morning. So this is how demand response means changing the usage pattern of the consumer. Okay? Anyway, so these are the things of a smart distribution system. Presently, penetration of renewable energy, DT, is around 3 to 5%. Okay? And up to 15% you can penetrate energy. You see a lot of energies are available. That energy is environmental friendly, renewable, always available. Solar, wind, everything, they are always available. So you should tap this energy and put it for the benefit of the society. Demand response I have already spoken, self-healing we have discussed. Sensing, as I said, self-healing is not possible if you don't have sensor. If you have some medical problem, you go to the doctor, doctor advises you take some investigation, go for testing. These are investigations. What are sensors doing? They are investigating the health of the power companies. Consumer devices, as I said, should be smart enough. Consumer devices are well informed by the utility. They have a program pricing chart, tariff. Your device know this time the rate is high. I should not switch on the electric iron or washer at this time. So they will be off when the prices are high. So your consumer devices will be smart, optimizing distributed assets. Then there should be an optimization of different resources, solar, wind and all that. Okay? So for daytime, your solar should be on. For night time, your wind should be on, like this. Okay? So you have to decide, because in the morning there is change in temperature, so wind speed is very high. In the daytime, wind speed is constant, so no wind energy, solar, solar, solar. In the evening, again there is a drop in temperature, so wind again starts blowing. So these you have to coordinate, so optimize the distribution assets. One conductor is loaded, you know, losses are proportional to I square R, so if current is increased by 2 times, losses increase 4 times. So try to cut down the current here and increase the current somewhere else. So these are the, we call it optimizing distribution. Then there is islanding. What is the meaning of islanding? Again, this is for all people. What is the meaning of islanding? No, what you want is like you want a system where the system is big and connected, yet independent. I mean, you have a smaller system all around. What we think in electrical system, that we should have our own system, but that system should have a communication with bigger system. So we want a big grid and this small grid. So that if I have problem in small, then big people can help me. But if big people have problem, I can cut down myself from that big thing. So we call it islanding. Selective islanding. If you have sufficient generation, sufficient load, so you can cut down from the grid when in the case of emergency. And this we call islanding. Okay. Challenges not. I will not go into the detail of this. Now, what are the problems presently? What are the problems in the existing system? Again, these are some technical things. There are a lot of losses. System is unbalanced. One phase we are getting 230 volt, another phase 180, another phase 150. Sometimes in the village, if you go, the voltage is not to the mark. So these are, abnormal condition, and abnormal condition always give rise to losses and poor efficiency of the system. So we need to improve all this. Secondly, the computer power electronics loads are non-linear loads. The system was designed for linear loads. Non-linear loads are increasing losses in transformer and transmission lines. So you need to handle those non-linear loads. Okay. Then reactive power demand, again the power electronic based power devices with demand machine. They are using machines, they demand high reactive powers we have to control and be able to. These are the remedies that we should use. Okay. These are the objectives that we can achieve. Again, phase balancing, as I said, the problem which increase in losses. Now, what is the conclusion? The conclusion is more energy efficiency and conservation, optimum utilization of available resources, reliability of power delivery and safety of power, adding more clean and green power to the system. This is what we are planning. Optimizing environmental benefit, resilient and stable network. The grid should be secure. If you have a small disturbance, it should not go into black. The grid should be resilient. Informed participation of consumer. Consumer should know what I am paying for. आपसे कहें 10 रुपए दीजिए, आपके क्यों दूँगा? Tell me why should I pay you 10 rupees? So it should be informed participation. The consumer should know why I am paying this much amount. Reduction in, but ultimate aim is, because the business model. This is a business model, competitive business model. ये 2 रुपए की बेच रहा है, मैं 1.5 रुपए की बेचूंगा, ये सवा की बेच रहा है, मैं 1 की बेचूंगा. So reduction in per capita cost. No. So these are the summary. So in today's world, we need to utilize all available technology in planning a system that is as energy efficient as possible. So basic aim is we need to design a system which is as energy efficient as possible. There is no optimal as far as energy usage is concerned to keep on improving. This requires total change in attitude, total shift in your mindset, change in attitude in the way we approach power system planning. It's a famous scientist, what he has said, listen this, read this. We can't solve problem by using the same kind of thinking we used when we created them. So now, what you thought earlier, now you cannot advance if you are in that loop. You have to rethink, and then only you can progress. Thank you very much for your attention.